Okay, so I'm going to talk through some of the. Am I off? Okay. So hi, my name is Ed Brain. I'm going to talk through the latest set of updates to the BP SEC document. We just posted a -01 several weeks ago. Next slide. So a summary of the changes, and many of these were discussed both at the interim meeting in January, and then we had some follow-on discussions on the mailing list. We removed the authentication block, the BAB. We removed the concept of security destinations, partially by removing the bundle authentication block. We removed bundle canonicalization. We simplified the block identification, and we are updating some of the security block formats to match the BP biz that we just talked about. So I just want to walk through each of these in turn and then present the work that we have ahead of us to finish the document up. Next slide. So the rationale for removing the authentication blocks, I wanted to just mention this one more time because it has been somewhat controversial in terms of the authentication block is a natural thing that we want to do, and describing how we can get the same kind of capability with a different set of primitives is an important distinction. We treat authentication as a special case of integrity, particularly integrity marking information from our last hop. However we choose to define that last hop. One of the issues with BAB had been what exactly is the previous hop? Is it the previous link hop? Is it the previous bundle level hop to the latest BPA? Or is it the previous bundle level hop to the latest BPSec enabled BPA? And those are all different things. We came back and said we do need authentication, but we don't need a dedicated BAB block type to achieve it. So then the natural question was, if BPSec is not going to have an authentication block, how are you going to achieve authentication? Because we need to make sure that that recipe exists somewhere and somehow in order for us to remove it out of this specification. So we came up with at least 5 ways of putting this forward, and I'm sure there are more, and perhaps there are fewer. And the thought behind this is to have a separate document called Security Practices, and there's a draft for that, which will describe how you take policy and cipher suite and protocol and other protocols like BIBI, not that encapsulation is the be-all and end-all, and put it together to get common security services back. So the reason we present these here in the context of BPSec is to justify why we feel we don't need an authentication block. First level is to simply say we use trusted convergence layers where they exist, and if we have trusted convergence layers in our network, then we don't need to do the authentication at the bundle level at all. Ergo, we don't need a bundle authentication block. Another is we can sign a single block representing a previous hop, such as the previous hop extension block PHN with the bib, and that will give a secure signing from something that came from a previous hop. Clearly, that doesn't provide integrity over the rest of the bundle or other blocks, but that is appropriate for some network deployments if that is sufficient. Certainly, another and perhaps more heavy-handed thing to do is to put a bib on every block that's in the bundle, primary block, payload block, and every extension block, and look at those and evaluate them hop by hop. That would certainly give you per hop authentication in everything in the bundle. The fourth way is something that we're going to talk about towards the end, which is a question that came up. Do we want to support multi-target BIB and multi-target BCB blocks, which is separate than saying we don't need block multiplicity, and we'll cover that in a different slide. But if we had a multi-target BIB, you could have a single BIB with multiple targets as opposed to multiple BIBs, one for each target. And the question out is that yeah. And then lastly, we could define a separate block which represents a hash over the entire bundle, much like the BAB block required you to compute, but you could compute that as a separate block and then sign that separate block. In which case, having a block that has a bundle-wide hash signed with the BIB gives you exactly the same functionality that the BAB gave you. So between these 5 and perhaps others, we feel that there are ways that we can get authentication in a network as a matter of policy and network design, as opposed to requiring the bundle authentication block and the bundle canonicalization that is required by it. Are there any questions about removing the authentication block?
Kevin Fall again. Just a recommendation from you, since you've thought about all these options. If I just want my delivery chain across to include the usual case I use is the written on the wall bundle, right? When somebody writes the text of the bundle up on the wall, goes away, somebody comes later, copies it back, and it continues on its way. Sort of the avian carrier version. What is the recommended one of the ways, would you think, of, given you studied this, as the way to achieve that in that case?
Well, I mean, the question back is how much of what is written on the wall is to be authenticated. Right? So if the standard, although hand-wavy answer is anything that you want authenticated needs to be signed and securely signed, and that secure sign needs to persist. The question becomes two things. One, what are you authenticating? So let's presume it's the entire bundle.
From an application, it's a data block, right? I have some data got into the network somewhere. I want it end-to-end authenticated, but it's not going to be in a...
But is it the class of service block that goes with it? Is it the extended time block that also goes with it? We can make the assumption that
let's say yes. Let's say yes to all those.
Then the next question is, at the ultimate destination, which has gone n hops route, do you want to be able to look at the authentication step from each method or not? So there's certainly the end-to-end case, but do you want like a trace route? Do you want that?
Yeah, it's the end-to-end case. I think that's more the question.
Because the point is that BAB as on its own would not provide that end-to-end case either. Right. It's thrown away at each hop. In this case, I say that we actually have a better capability, because in that case, if we created, for example, a hash over all of the blocks, you could have multiple bibs that come in, and you could look at them and make and say that it was authenticated at each of those, and you get a history out of it.
That requires an addition, though, to what you have. You're saying, right?
Well, I think that at some point, if you want a bundle-wide hash, you have to generate a bundle-wide hash. We want to take that out of BPSec and say that that's for someone else to define. I'm sorry, does that answer your question? Did I hand wave enough to answer?
That last comment answered the question, actually.
Okay. All right, next slide. So additionally, we looked at security destinations. They have been somewhat problematic in 257 in the sense that the concept of a security destination coupled routing and security. That if you specified a security destination that was not the bundle destination, you made an assumption that the routing system would take you eventually through the security destination before getting to the bundle destination. And then there were certain cases where you got to the bundle destination before you got to a security destination. What do you do at that point? So in the SBSP, the Streamlined Bundle Security Protocol, one of the simplifications that was made was to assert that the security destination could either be the next hop, if we were doing authentication, which SBSP had, or was forced to be the bundle destination, and everything was looked at the bundle destination. And that if we wanted to do something different, one way of doing something different and having intermediate destinations was to use tunneling of some sort, using perhaps Vivi to go to endpoints in a tunnel. At the end of the last IETF, we had a breakout security session after the working group, and we said that is perhaps too restrictive, and one of the things we should present in the stack was to remove the concept of security destination completely. That if you assert a security source, that as a matter of policy within the network, individual nodes can determine whether they should or should not be evaluating a security service. A common example is if you assert integrity on a block, it is perhaps allowed that every waypoint along a bundle path should be able to verify the integrity of the block or of the bundle and throw it away if it is not correct, and not have to wait until you reach the security destination to realize that you have an inauthentic bundle or a non-authenticatable bundle. And that can be something as a matter of security. There are other cases where perhaps if you are moving from one trusted enclave or subnetwork to another trusted enclave or subnetwork, that you have an encryptor at border nodes. And perhaps if you are encrypting at a security source that is separate than the bundle source, you may want to decrypt at a boundary to another area as opposed to the ultimate bundle destination. That is something that can be evaluated by looking at the network security policy and understanding who the original encryptor of the bundle is. So we saw no reason for keeping the concept of a security destination in any of the BPSec blocks. Are there any questions about removing security destination? Okay, next slide. So there were a few other updates which were smaller in scope and predicated upon the other two changes. One is if we don't have bad blocks, we don't need to specify in the BPSec a whole bundle non-equalization and hashing and so on. And so we have removed that section from BP. The idea behind that is if someone wants to do whole bundle hashing or multi-block hashing, that is not the whole bundle, that those are activities that should be left to other users and other specs. And BPSec would say if you do create such a block, then you can have a bib and a BCB to protect them. But in the interest of separation of concerns, the BPSec doesn't need to take that on. The security practices document, however, could make recommendations on when you would want whole bundle and when you would want multi-block hashing, so that you could then use BPSec to protect that information.
Kevin Folligan. So just since it got brought up in the BP, in Scott's presentation, if we were ever to the point of having this manifest structure defined, it seems like it might be quite related to this first point. Would you concur with that?
I concur. And actually, we can talk a little bit about from an inventory perspective. And when we get into what is in the manifest block, that could be terrific, because if the manifest block is the set of blocks that exist and a CRC on those blocks, then by simply signing the set of CRCs on those blocks, you get something similar to whole bundle hashing. We simply, if those who recall in SBSP, we did not have block unique identifiers. So we made the assumption that block type was enough to uniquely identify a block in the bundle. And because of that, and because we might have multiple bits or multiple BCB blocks in security and perhaps other use cases, if block type was not enough to uniquely identify a target of a security service, there was a large, about a page-and-a-half portion of the spec that talked about how you might jam an identifier into some of the source specific part information. We can take all of that out now because in BPPIS we have a block unique identifier. So that's what that second bullet is. The target block is now the block unique identifier of the target block, as opposed to trying to insert and extract out of block flags EIDs, but which themselves have kind of gone away in BPPIS. So it just all made sense. And lastly, there are a couple of changes to update BPSec to track changes in BPBiz, like changes to block headers and so on. And we're not quite done that third part yet. So as BPBiz goes through last call, we'll have to make, obviously, a big scrub of BPSec and make sure that everything in BPSec is conform with what is in BPBiz. Next slide. Next slide. So there were some plan changes and then some open questions. Right now, we are doing some analysis of BPSec against common attack vectors, what happens when blocks are changed, added, and removed, and what is the perceived resiliency to that. One of the things that's coming out of some of those reviews are perhaps it would be good to have recommendations for Cypher Suite developers. One of the things we felt strongly about was the protocol document should not mandate Cypher Suites. However, it can give guidance and recommendations for Cypher Suite developers. It says, if you are writing a Cypher Suite for the BPSec, here are some things that you should be aware of. Similarly, for policy developers, we did not want to encode policy with BPSec because we could see the BPSec protocol being deployed in multiple networks with different security policies, but recommendations for policy developers is also an area that we would like to put a few things in. And right now it's looking like we have, just by weight, a half a page worth of recommendations in each of those areas, maybe 5 or 10 things to be aware of. Additionally, it was recommended that some assumptions and constraints also be put in early in the document to try and describe what will not happen or when you should or should not apply BPSec based on that. And then there are a couple of those coming in. So I list this not because there's data to look at right now, but in the next version of the document, we will have initial drafts of these to look at going forward. Next slide. So a couple of questions. The first is, can we remove the first and last block concept? So with bundle authentication blocks, there was a consideration that you would have a pre-payload block app, which had cipher suite parameters associated with it, and a post-payload BAB block, which would have the security result. And the thought behind that was, if you were trying to ingest an enormous bundle payload, you know, a gigabyte or terabyte payload, that you clearly couldn't keep all of that in memory, and what you could do is you could look at the first BAB and take the parameters that you would need to generate an integrity result, and then as you block processed individual pieces of the payload, you could off in memory be holding a running total of the hash result, and then by the time you got to the end, you could simply compare the in situ evaluated hash result and the hash at the end. What we looked at from that point of view, and clearly some of that is moot because BABs aren't there anymore, but you could see a bib operating in the same way. And one of the things that, a point that we wanted to make, well, 2 points we wanted to make. One was, in that scenario, if the security result was in the first block, holding the security result in memory is probably not that much of a difficulty, or even holding it off on disk is not that much of a difficulty for an implementation, which is already having to hold off a context for the block hashing algorithm or signing algorithm. And therefore, you can have it in memory, and by the time you get to the end, it's there, and you don't need a post-payload block to store it. The other is, in BPBiz, one of the things we wanted to do was assert that the payload block would be the last block in a bundle, and then you also can get rid of perhaps the last block, you know, this block is last block in bundle. So given that, we can't think of any reason why you would need 2 instances of a security block, one before the payload and one after, or one before the security target, one after the security target. So we can simplify the entire discussion of first blocks, last blocks, lone blocks, and just say a security service is 1 block. Are there any comments or questions or recommendations for whether we can get rid of first blocks and last blocks?
Got it. Yeah, we're back.
So if we, so correct, and I think that's so Scott has said that at the last meeting we affirmed that the payload block would always be the last block in a bundle. Now, for this discussion, you could have a security target that is not the payload block. So if you were doing a bib on another extension block, you could, by the spec, have a pre-security target block and a post-security target block, and I just think that's a very bad idea, and would like to just have lone blocks. Okay. Another open question, which I don't know that we will solve here, is the bib and the BC block is currently defined only look at their security target. They don't re-sign themselves as additional authenticated data. And the question is there value in, for example, a bib, which is creating a signed hash on a target block, to also include its own parameters and contents of the bib block as additional authenticated data to that signing, either by serializing the bib and attaching it to the security data and hashing it, or just keeping 2 separate hashes, one for the target and one for itself. So one of the things that's looking through the security analysis is that is there a vulnerability where someone doesn't change the target but can change a cipher suite parameter, switch an IV or a salt to force something to fail its integrity. And you know, the analysis right now is saying, well, we can detect if something has changed, but the result is going to be the same. The result is, you know, if you change something and we detect it, or you change something and we don't detect it, you're going to fail the authentication either way. The question is there value in understanding why you failed the authentication? Either because your bib was changed or because the security target was changed. And that's probably going to be one of the other questions that we posted on the list. And then the last question was, when we created BPSec, there was a big push at the time to represent or to be able to support a representation of the cryptographic message syntax block for those networks which deploy CMS and want to use that. And really, there's a general question of, is this something that we want? Is this something that BPSec should be supported and inclusive of, or is this a separate security approach? We can go through in BPSec in the next version of the document and make sure that we've really scrubbed the interactions between BIB and BCB and CMS. And that is certainly the path we're on now. But a question out to both the mailing list and to this group is, do we need the CMS block? And is it worth carrying this forward as we go through our investigations?
Well, I've answered with NASA, Glenn. I haven't really followed this real close, but I do communicate a lot with the CCSDS people. I believe they're putting this in the CCSDS group.
So I don't know what CCSDS is doing, but if there is a reason to put this in for interoperability, we can keep it in.
So is Scott on from the CCSDS meeting? Is that where he's calling in?
My understanding, until Scott comes in, is that some stations already use CMS. And if they want to be set, they may use CMS embedded targets CMS on flight, but the ground stations are. So there is, I believe, CMS blocks within Next slide. And then the last question is one of the things that we know and perhaps you want to for that set. Security source could be the same. So in case do we want to allow special cases where multiple security sources in one big an important point here is not saying we don't need block multiplicity. So this is perhaps a niche case where you don't want that information redundantly in multiple groups of these. So this is that we also take the mailing list. There are some associated. And I think that's my last. So update to the spec probably in the next 3 to 4 months. It will have some of these changes, and we'll also post some of these open questions to the mailing list. And the request is please look at them and chime in if you have an opinion.
Marc Blanchet, about the CMS thing, it looks like since it's maybe used by some people, but not everybody.
With me, the value in having the CMS block in the BPSec is that we've had to put some rules in place for how you make sure that BIBs, BCBs, and CMS blocks don't clobber each other or have unintended consequence or dependencies. But you could also break those into 2 separate documents and handle those in a security practices document.
Or in the CMS document.
Or in the CMS document itself.
Therefore, if you use this, then be careful about this and that. But
yeah.
One of my, consideration for this is, simplify as much as possible the implementations. The more we put, all kind of stuff, it make this, super complex.
Well, that's a good thing. Could we vote on that? Or could we get an initial sense of, do we want to take CMS blocks out of BPSec, make them their own document, and have BPSec be BIBs and BCBs?
Kevin Fall. It just seems to me the criteria to use to answer that question is how many people care about it. If the people, and are they all a member of one group that is independent? So, for example, if it's all CSDS that wants to do that only, and there's not evidence otherwise, maybe CSDS should standardize that use.
So my understanding is that CMS, is used in IETF quite a bit. So the question is, would a ground user of DTN want to use CMS for security? That seems reasonable outside of CCSDS.
Right.
Rick Taylor, just a quick comment about splitting out the CMS stuff. I want to use BPSec in my DTN implementation, but I have no need of CMS. And so I would much rather have a single document which I can say, yes, I'm entirely compliant with, keeps my implementation nice and simple. It seems obvious to push the CMS stuff out to a second document. If people are using it within the IETF, then sure, let's do the work in this.
Make a decision. We can discuss it much in the way that Rick was saying. Simplify it for this and let them worry about it if they need it.
So how do we then understand guidance for 03? Because my default position would be in the next version of BPSec to remove the CMS block and perhaps make an internet draft for the CMS.
Rather than spinning the documents to do that, we could just have a discussion on the mailing list to see if anybody really complains about it first.
Sure. Yeah, I'll add that as a discussion and then.
Yep. Make life easy.
Okay. Well, thank you very much. Can I leave the box?
So now is the present study. Remote
Fred or your colleague, can you start speaking to see if we can hear you?
Hi, this is Kapali. Hello. Okay. Thanks, Scott. So I think you're able to hear me. Okay, I'll start the presentation now. So this presentation is about the public key distribution network, PKDN, for DTN security key management. If we can go to the next slide, please.
Cool, we hear you. Thanks.
Okay.
Can you start over since we just heard your last sentence? So let's start over.
Okay. So I'm just starting over. So this presentation is about the public key distribution network, PKDN, for DTN security key management. Can we go to the next slide, please? Okay, so this is the overview of the presentation. We'll give a PKDN overview. Then we'll go to the PKDN entities and functions, followed by PKDN vis-a-vis the DTN key management requirements published previously, and the changes since the last version we presented in January. Next slide, please. Okay, so this is the PKDN overview chart we wanted to share with you. So there are 4 entities in the architecture, namely the sender, which initiates a session, PKDN session, with the receiver through a validator. So that's the normal session management path that we see in the horizontal side. And this session management is interrupted by a certificate revocation manager, and which is in the revocation event propagation path. Now, the publish message flow from the certificate revocation manager to the validator depends on reliable DTN multicast. That is, we require a reliable DTN multicast to reach only until the validators. We expect there to be a few validators and many senders and receivers. The sender will choose the validator by configuration or by discovery. But as of now, to keep it simple, the proof of concept that we are developing is using implementation by configuration. Next slide, please. So during our previous presentation, there was a discussion about the layering for PKDN. So that's why we introduced this diagram. So we see that the entire PKDN layering is on top of the bundle protocol. So we expect every node to have a sender and receiver function, and there are validators that also operate on top of the bundle protocol, and that could be one or more certificate revocation managers which also operate on top of the bundle protocol. And we expect all these entities to be interconnected via a delay tolerant network cloud. Next slide, please. So just to understand where PKDN is useful in the public key management path. So this is a generic public key management lifecycle. So the key is generated, and then the key, and then the key is associated with an addressable identity. And once that event has happened, the key can be used in the system. That's the key use block. And until one of 2 events happen, either the association has expired, in which case the key goes to disuse, or the association has been revoked, in which case also the key goes to disuse. Now the role of PKDN is in the key association stage, the key use stage, and the key revocation stage. In the key association stage, we assume any key association protocol like the X509 public key infrastructure software. We can use that standard or any other certification standard. And PKDN references these association or the certificates uniquely as a key fingerprint and expiry timestamp. The fingerprint can be a hash on a certificate, anything that's going to provide a unique handle onto what that association event is. And in the key use stage, PKDN provides an in-band mechanism to exchange validated certificates. And in the key revocation phase, PKDN will help the certificate revocation manager to propagate the key revocation events to the validators, and the validators can filter and send interested events to the endpoints. That's basically the sender and the receiver. Next slide, please. So now we come to the entities and functions of PKDN. Next slide, please. So we will be talking about the subscribe aspect. How does so whenever there's a validator that is plugged into the system, it will subscribe its interest in receiving revocation events from the certificate revocation manager. And as a confirmation of the subscription, the certificate revocation manager will send the current CRL to the validator. So at that stage, the subscription for the validator is complete. Next slide, please. Once the subscription is complete, the certificate revocation manager will push any new additions to the certificate revocation list as events. And when the validators receive those system level events from the certificate revocation manager, the validators will filter out events of interest for specific senders and receivers, and it will only push those events that are of interest for the sender or receiver. Now, how the validator will know which sender is interested in which certificate event or which receiver is interested in which certificate event, we will see in the session management side. So at this stage, we have just seen how revocation events propagate in the system. So one as a multicast from the certificate revocation manager to the validator, and then filtered unicasts from the validator to the senders and receivers. Next slide, please. So now that the certificate revocation event propagation system is in place, this slide shows how the sender and receiver can exchange their certificates via the validator. So the sender sends a public key certificate to the receiver through the validator. At this point, that's on the left-hand side between the sender and validator. The validator checks if the public key certificate of the sender is valid, both cryptographically as well as in time, that is, it has not been revoked. And if such is the case, it appends an authentication and sends a validated public key certificate to the receiver. And upon receiving such a certificate, the receiver will send its public key certificate, that's the arrow from the right-hand side to the left-hand side, to the validator. Validator does exactly the same operation as it did before and sends a validated public key certificate to the sender. Now, during this interaction, the validator is going to record the interest for the sender on for the receiver's public key and for the receiver on the sender's public key. So this is how the validator knows the interest in the certificate of interest in the certificate. And once this exchange has happened, the sender and receiver can engage in secure communications, and those communications need not have to go through the validator. They can go outside the validator. So this is a one-off session establishment kind of cycle. And these sessions are valid for a very long time. These sessions are not like an SSL session. They can be valid for, that depends on the policy of PKDN that is there. It can be for 8 hours to a few days, depending on the delay and disruption properties of the DTN over which the PKDN is laid. Next slide, please. So at this stage, we have completed the PKDN overview, entities and functions. I can either take questions now or later on the PKDN before we proceed to the key management requirements. Okay, I'll go to the next slide, please.
This is Ed Brain. I just had 1 or 2 questions.
Yes, Ed.
You may have covered this before, but how do you validate yourself from validator?
Can you repeat the question, please, Ed?
So if I am communicating with a validator, how do I understand that I am communicating with the validator that I think I am communicating with?
Yes. So the validator authentication, even before the subscription happened, so the general key management assumption is every entity knows the certificate of the certificate revocation manager. That could be either one or more than one. We'll assume there's only one certificate revocation manager for this context. So every entity will have the public key certificate of that certificate revocation manager. And the certificate revocation manager is going to issue certificates to validators. And if the validator has a valid certificate from the certificate revocation manager, then it can be a validator. And that is how trust is bootstrapped throughout the system. So the root of trust is a certificate revocation manager, and every other validator public key is certified by the certificate revocation manager.
And that happens out of band from this protocol. Is that correct?
That's correct. The root public key of the certificate revocation manager must be physically configured onto every device, whereas the validator's public key certificates need not be.
And then just two more questions. One is, and I apologize, I have not had a chance to read the spec, so maybe I shouldn't be asking questions. Is there a assumption section in the specification where you can capture these assumptions, for example, what is configured out of band from the protocol? Yes, it is already there in the draft, but I can state it explicitly as the bootstrapping assumptions. I can make it as a bootstrapping assumptions on that. Would that help? The last question is it the intention that the keys distributed by this mechanism be the long-term keys, and session keys would be still negotiated between senders and receivers using a separate mechanism? Yes, that's correct. So over here, we are only distributing the long-term keys and the revocation of the long-term keys. Thank you. There any more questions?
Yeah, Kevin Fall again. So in the depiction, the full operation of this depends on a reliable multicast DTN protocol, I think, correct? Which was an unsolved.
Yes. So
okay, let's assume that we proceed, and we have something that in certain, because we do have reliable multicast protocols that kind of work on. And so in those cases it might work, but what's so from a standard setting point of view, what does that mean? I guess that's sort of a chair question. But then the other one is, technically, if we have this DTN multi-reliable protocols that does something, and it winds up distributing different bits of information over time to the different validators, what then happens? Because it seems like your choice of validator will give you a different behavior with respect to when you go to the different ones, which is then ties it back into the routing again.
Yes. So I heard two parts to the question. One is on the reliable multicast between the certificate revocation manager and the validators. And the second is, can I get the second part again, please? I'm sorry about this.
Well, assuming that you had something like that, it would be the case in general for a DTN that you'd have different information conveyed at different times, so the different validators would have different state with respect to the CRL.
Correct.
And so in that case, what winds up happening with respect to your root selection, or rather your validator selection, during the exchange? And is that a
correct
vulnerability?
Yes. So yeah. So they're both good questions. I'll answer one by one. The first one regarding the dependence on reliable multicast is We just want all the events from the certificate revocation manager to reach a given validator. So this can be achieved in two ways. One, a DTN reliable multicast, or two, using a Twitter follow kind of semantics, a publish subscribe. So you can either go unicast, so that the certificate revocation manager will send a bunch of unicast. It will basically unicast the same message multiple times like Twitter does, or we can do the DTN reliable multicast if one exists, because it will be a more efficient technique. That's for the first part of the question. The second part of the question is about the consistency of the revocation information between any two validators in the system. Now, because there will be a delay and disruption, which are not predictable, the system can only guarantee eventual consistency, meaning all validators will eventually be in synchronization. They will not have immediate synchronization of data. So in order to do that, every session is specified to have a finite time. For example, let's say a session is valid for 8 hours. So when the session is valid for 8 hours, after the 8 hours is over, the session has to be reinitiated if the sender or receiver is interested in the session to be kept alive. Now, the event in this case is when the 8 hours is over, suppose the key has been revoked during this 8 hours, and the revocation event has reached the validator, then the session gets disrupted. If the event does not reach the validator within the 8 hours, that means the session gets naturally expired. So one of these two ways, the session does get expired. And when the session gets reestablished again, at that time, again, the session establishment goes through the validator, and that's another chance of checking if a particular public key has been revoked or not, in which case the validated public key will not be sent by the validator. So these are all the checks that are put in place. There are multiple ways of catching, multiple periods of catching the event, assuming eventual synchronization. Did that answer the question?
Partly, I think, but I'll just wade through your next bullet because it seems like the end point now needs to be cognizant about its periodicity with respect to its engagement with validators. And I'm wondering how it sort of selects them, because it's path dependent, I think, based on your validator selection.
Correct. It is path dependent, but the session has a finite duration, validity duration, which is not path dependent. Let's say it's
Mark, here, co-chair. As we agreed, the purpose of your presentation was to talk about requirements, because that's what is in the charter. Yes. I'm getting concerned that we spent a lot of time on the solution while we haven't discussed about the requirements, which was the purpose of this. And time is flying, so I'm not sure what to do, but
then we can, yes, please, then we can go to the next slide, please. Okay, so these were the requirements that were established for the DTN key management previously, and the first one is must provide keys when needed. So this is where the session establishment protocol is there. So the receivers receive validated sender certificates encapsulated with initial message bundles. So it is possible to make the keys available when needed by encapsulating the long-term key goes through and putting some more allowing messages to flow during the initial stage. That's the validated public key stage. So that's how we can realize the first requirement, must provide keys when needed. Second requirement that said that the key transfer must be trustworthy, and this can be realized by using trusted authorities like the certificate revocation manager, and again with the ability to revoke the keys. So that's how trustworthiness. Trust is basically from the certificate revocation manager, which can be one or more. Again, we say that there should not be a single point of failure. So that is a requirement over here. And we can have multiple certificate revocation managers independently, or there are also, we can say 2 out of 3 certificate revocation managers must sign. That kind of trust failure, we can ensure that we can distribute trust using digital multi-signatures. And the second way is by having path redundancy from the certificate revocation managers to validators. So this is requirement 3. This is how they can be met. And requirement 4 is multiple points of authority. As I said, we can have digital multi-signatures. We can have more than one certificate revocation manager. And in fact, the certificate issuance and certificate revocation are kept as 2 separate trust parts. So the person who's issuing the certificate need not always be the person who revokes the certificate also. That way, we don't have multiple points of authority necessarily. And the 5th requirement is no veto. And again, this goes with requirement 4. So the validators, senders, and receivers are all configured to make their own local decisions. Now, this is unlike OCSP, where the decision to accept or reject a certificate is made by a central certificate on behalf of any browser in the world. Whereas over here, the validators, senders, and receivers make their own local decisions. So there is no veto. Next slide, please. Must bind public key with a DTN node identity. This is possible because we are using, for example, we can use a X509 certificate, which naturally binds a name with a public key, and the name can be a DTN node identity. Like on the internet, the name is a URL, and we can actually replace the URL with a DTN node identity. So this is also possible. Must support secure bootstrapping. Now, that's the question we answered previously, that the keys are the root public keys of the CRMs and the trust authorities are actually configured manually on the entities once in their lifetime. And requirement 8 is must support revocation. So the entire system is possible to support revocation in the DTN setting. And revocations must be delay tolerant. And again, because we saw that it is possible to overlay all the entities over DTN as a strict overlay, and using event-driven semantics, it is possible to achieve requirement 9 also. Next slide, please. And one more slide, please. The changes since last version, since January. So one is from a semantic point of view, we have changed the draft file to align it to the working group convention, naming convention. And the second bullet point, we are now using unicast certificate revocations for the interested parties. That's from the validators to the senders and receivers in response to a feedback that we got in January. Now this keeps the roles of senders, receivers, and validators separate. And the third bullet point is PKD and validators remember the certificates of interest. This is a consequence of the second bullet point. And we have also introduced a limited time period for the security sessions. In the previous draft, we assumed that the sessions were valid forever. This is not the case in the current draft. And senders must send fresh certificates through the PKDN validator before the validator interest memory expires. So these are all the changes since January of this year. Next slide, please, and that concludes the presentation.
Kevin Paul, might as well up again. So, the question that was the requirements versus the charter item e-management requirement that, for example, might possibility of IBE, or is it a particular system?
I lost the audio feed there a little. Could you please repeat the question?
I'll repeat, Mark here. I'll repeat. The question was, what is in the charter, and the answer is requirements. Now I'm asking my own question, which is, I think in the list there are two kinds of requirements that you put. One are generic PKI, requirements that are, well known and could be copies from somewhere, and then what is, special in the DTN environment. And I think we should really separate the two and focus on what is specific to DTN environment, because inventing the requirements for generic PKI is, I'm not sure it's the word needed here.
Ed Brain, just a comment. When we start putting down the requirements, and to agree with Mark, there are lots of requirements that we can pull in this area, but it would also be good to have a rather large set of assumptions and constraints that come in as well, because through the reference architecture that is perhaps driving the requirements, I think I noted 4, 5, or 6 very large assumptions that are being made, which is fine if they're documented and agreed on. And there are probably some constraints on the system, especially if you pull requirements from somewhere else. So I would just lobby for a nice set of assumptions, constraints, and requirements.
It's Kevin again. I just wanted to expand on a slight thing I was implying there before. I agree with Ed's comment, but also, there's a significant amount of work in the area of key distribution in a DTN setting using identity-based encryption, which has a little bit different properties, but probably could be written down in a requirements document that melded them together. My concern is that, again, separation of concerns a little bit here, is that there's some requirements that come straight out of PKI world that probably include identity-based. It's okay. And then maybe some other ones that might be a little more iffy, and then probably some special things that are implied by the DTN environment. Have that come out and be separated from the particular solution architecture that seems to have some extra requirements or assumptions, I think would be helpful.
Mark here, I do agree with that approach. Is this kind of the general consensus of next steps for this? People, yes? Don't care. Not sure. I saw a couple of yes, but and a lot of not sure. My co-chair thing. So I'm proposing to have focus only on requirements and try to have, like Kevin was saying, like a generic for the special. And that makes sense.
Rick Taylor, I appreciate what this work is trying to do. Particularly, I can see why they're trying to solve the problem as well as specify the requirement, because we are engineers. That's what we do. I just get the feeling that the assumptions section that needs to be in this document is going to be big. Not just the reliable multicast, but also the temporal consistency, etc., etc. of the solution and possibly even in the requirements. And I get the feeling that a lot of this work is based on the assumption that DTN is a lot more advanced than actually we currently is. So if there's a polite way of saying I think this work is valuable but should be delayed until we're much more settled, that's all.
Right. So as the other co-chair, I agree that we really need to understand what we're trying to do. And I completely agree with Rick's point of view that it's probably a little premature to be trying to talk about some of this stuff right now.
So similarly, as key management is key management. Management is in the requirement phase. So I asked Ed to focus on requirements.
So hi, it's Ed again. What I want to talk about today is the first half of a draft spec that's been published to the working group called Asynchronous Management Architecture. There is a body of work that's been going on for the past few years to define an asynchronous management architecture and asynchronous management protocol, implementations of that protocol, and then a series of data descriptions and command descriptions associated with it. And one of the questions back is, if we reverse engineer some requirements based on that, are we close or do we need to do something different? So that's what I wanted to address here. Next slide. I'm going to skip over some. I think we all understand the motivation for DTN. Presumably, we all understand the motivation for DTN. The use cases for DTN, we wanted to pull out just a few. One is obviously signal propagation delay. One is frequent link disruptions. But a third is link access disruptions. So there are times when you are denied access into your network, not because the link is down and not because you have long signal propagation delays, but because you're a lower priority user and you've just been bumped. And that is particularly a use case that we care about on the management side, where sometimes the performance monitoring data has a lower priority than the actual science or larger mission data. And in particular, we make an assumption that we don't have a human in the loop for closed loop communications. And that's a driving assumption around asynchronous management. So we, both in the spec and here, draw a distinction between synchronous network management, which is what I claim we do with SNMP, and asynchronous network management, which I claim we don't do well at all. Next slide. So just a little bit of history. This, some of the discussions on network management were in the 2010, 2011 timeframe. Will, you were part of that. Originally, we had some early pubs to try and figure out what the problem was. We reviewed some popular engineering approaches, looked at autonomous fault protection schemes, mobile code and scripting schemes, what spacecraft do to report their own performance requirements, deterministic rule-based expert systems. What we started pushing towards was this need to have a level of autonomy in the network management layer. And we do that on spacecrafts, and we do that on airplanes and UAVs and UUVs for fault protection. And the question is, can management be re-expressed as network safing as opposed to hardware safing associated with monitor rule-based systems? So we put something out called Delay Tolerant Network Management Protocol in 2013. We renamed it in 2015 to the Asynchronous Management Protocol because AMP sounded better, but also because DTN-MP implied that you needed to be running DTN protocols. And AMP does not require the DTN protocols. You can run AMP with IP or any other transport layer. It just so happens that it's probably also very useful if you're running DTN protocols. So that's all I want to talk about in terms of where some of this came from, and then just to spend the rest of the time talking about higher level concepts. Next slide. So how do we manage networks today, and do we need a new thing? I apologize for what is a gross simplification trying to fit all of this onto one slide. But in general, SNMP is a pull model. I know there are traps. In general, things like netconf are session-based, although I think a couple of years ago, Bob Cole put a proposal together to do non-session-based netconf, and I don't think that really went anywhere. And in general, the approaches that we have today don't scale well with delays, disruption, and my claim is that they don't really do the kind of expressive commanding that we need to create a safing network autonomy area. Next slide. So I captured high-level requirements in two ways. One is a set of service definitions for an asynchronous management capability, and the other is desirable properties. And we can reduce those to a set of requirement specs, or we can look at the AMA and say that that satisfies with some modification the requirements needs. So from a service definition standpoint, this is sort of a subset of FCAPs. If people are familiar with FCAPs, fault configuration, administration, reporting, and security. One of the things we felt was necessary was some level of parameterized control of your agent from the manager, which is detecting, diagnosis, reporting, correcting failures on the side of the agent. So one of the things that we presuppose in a DTN is that round-trip communication and pull and closed-loop control cannot be accommodated in the network. So when we talk about a network management protocol and a network management set of requirements, the agent itself has to be able to do parameterized control of itself in times when you cannot reach back or have connectivity to a manager. Similarly, and perhaps could be argued a subset of parameterized control is configuration. The agent must be able to update the behavior of its functions within the network, both remotely when you have a manager connecting or a local manager separate from perhaps a human manager, but the agent must be able to also, to some monitor response system, be able to change its configuration, perhaps for deterministic processing amongst a set of pre-considered or predefined configurations. Administration, access control lists, security settings, filtering the management functions by role, what managers can do which things on agents. That is also a service that has to be provided by this architecture. And finally, reporting of network conditions to operators and other nodes in an internetwork based on time and state local to the agent. So this really pushes us, no pun intended, to a push architecture. That an agent must be able to say, because of my local state, I need to apply a controller. Because of my local state, I need to switch to a configuration, or because of my local state, I need to generate a new performance result without being asked by a manager. And clearly time as well. I will produce health telemetry at 1 hertz, or I will produce a summary report once a day. And I can do that without a manager in the loop, so that even perhaps without connectivity, I have queued a set of reports that represent my state historically, and when connectivity does come along, all of that can come down and you can forensically reestablish what happened during that period of outage without being in the loop. The only other point I wanted to make to this slide is my claim is that when people traditionally talk about network management, they're talking about just the reporting aspect of it. I mean, there are some exceptions to that, but most of the expressivity of common network management approaches is expressivity in the performance monitoring and not expressivity in the administration and the parameterized control. And we think that that is a unique constraint on network management in an asynchronous way as opposed to a synchronous way. Next slide. So from that, we derived some what we would consider desirable properties. I felt requirements was too strong of a term for a first set out. So these are those. The first is the intelligent push of information. We assume that round-trip pull requests in the style of SNMP are not sustainable and not a good idea in challenged networks in general. Networks that are either challenged by link layers in a DTN scenario, or pull requests that are challenged by operator cognitive load or by priority access to the available bandwidth. Second was, and this may be contentious depending on the network deployment, but that we like to minimize message size as opposed to minimizing node processing. And the thought behind that was, yes, we could create very expressive and verbose expressions of commands and controls and things of that nature. But if we want a single mechanism to work in the very constrained and in the very resourced areas, going back to one of the assumptions that we have some challenge to access the link, either based on link characteristics or our priority within the link, smaller is always better, as long as perhaps smaller doesn't get so small that it becomes difficult to reliably implement. Another is that we would like specific data identification. What specific data identification means is if I want a particular piece of data, I do not have to generate and telemeter or send an entire report back to a manager, and the manager can then cherry pick the information associated. So we have to have fine-grained data identification, and then with that, perhaps tactical data definition. What that means is we want users to be able to generate their own report definitions that come back, both their own data definitions and their own definitions of reports that come down to be produced, for example, regularly. And then finally, we in the desirable properties or requirements, we say a deterministic monitor response system is a requirement of the asynchronous autonomy associated with this management platform. We want to avoid reliance on mobile code and scripting. That can be difficult for a variety of reasons. Script implementations, script engines, and in general the security concerns around free-form mobile code can prevent its adoption in certain embedded systems. But engine-driven applications don't run into particularly that problem, particularly if what you're sending up are configurations of a particular implementation and not free-form code to be interpreted and executed in situ. So those are the main properties, and then I have a set of slides after this that gives some examples one by one, and then after that, a couple of the data flows associated with it. And that's really all I wanted to cover today, other than by saying that there is an AMA document. Please read it. There is an AMP document, the Asynchronous Management Protocol, associated with this. And then there are, and we'll talk about this more, a series of application data models that are being generated as well. So in terms of reverse engineering the requirements, looking at any of these areas will help talk about what we mean by these desirable properties.
Sure. Hi, Nalini Elkins. As somebody who's active in IPPM and is somewhat familiar with LMAP, I wonder if this might be interesting for you to present over there to get, feedback from the performance metrics people. And also a lot of work, of course, has been done on LMAP in terms of the, the structure of controllers, agents, etc. I think your stuff would be of quite a good deal of interest to them.
Oh, sure. And I would be happy to do that. Thank you.
Great. Maybe we can talk offline.
Yeah, we'll talk about it. Next slide. So again, these are slides that were somewhat borrowed from another presentation. So I apologize once more for the oversimplification. But on the left, we would have an example of an SNMP manager and an agent, and this just shows the chatty nature of the protocol with pull requests. Whereas, and again, I apologize, the DTNMP manager and DTNMP agent. This was clearly pre-name change. Where the concept of operation here is if you want to collect data A at high rate, B and C at lower rate, you can configure that one time as part of what we consider autonomy rules, time-based rules or state-based rules. And you can, at a time when you know you have that configuration ability, send out and say, please produce A at a high rate, please produce B and C at lower rates. And that's really the only thing you need to do. And from that point, whether it is for the next day, week, year, or however long a defined predicate lasts, you will get your performance monitoring back without requiring other information coming out from the manager, which was one of the things we cared about. Next slide. Keep message size as small as possible. One of the things we want to do right now is not include names with values. So not necessarily an XML representation. We believe that much like MIBs don't require you to share the schema in real time because the schema is known on either side. We wanted to produce what we call application data models that have pre-published the well-named data, and you don't need to have particular data types. We do allow, and it is expressive for people to define tactically their own data types, and that schema and definition can also be pre-shared, but in situ, we are dealing with pre-shared schema types to reduce the overall data size. Next slide. For specific tactical data definition, and I pull some of this from the ION implementation, which is where the reference implementation is started. If we had, for example, bundle protocol data, LTP data, and general ION ICI data, we want the ability for users to create their own custom report. Define those custom reports one time, send them up to the agent and say, here's a new report separate from the reports that you have to handle because they are defined in some other guided document. And this can be tactically defined for users in your network. And then you can simply say, here's my mission, here are the standard reports, here are the custom defined data definitions and the custom defined data reports that my mission will use, and then your operators can simply request those reports as if they were well defined otherwise. Next slide. So how do we start specifying this information? Many people are familiar with the MIB model, which is very well named data. We came back and added a couple of other items and some syntactic sugar to this model. One of them, we called it the application data model, or the ADM, simply to differentiate it from the MIB because they're different. The application data model has in it atomic data values, which is much like a MIB, the data that would be measured directly from a device and firmware. It has computed data associated with it, which is sort of down at the bottom, which is real-time computed data that can either be computed once and held or computed on every evaluation cycle, again, similar to what we can have in a MIB. What we've added are a set of controls, much like command opcodes, which would also be well-known and published by a registering authority, and a fairly expressive parameterization scheme by which the controls and the opcodes could accept parameters, both asserted parameters by the original configurator or pulled from dynamic state from computed data items in situ. And then we also provide the ability in the ADMs to define your own constants and special operators, and those special operators could be used to create predicate state evaluations in our autonomy engine or evaluation engine. And then, much like controls, we have collections of data, much like macros. So we came back and said a very expressive parameterized control syntax, the ability to compute your own data, the ability to define in the ADM special operators, that gives you a level of specificity that gets us to an autonomous management function that we really don't see anywhere else. Importantly, this application data model is published and reviewed and static. So we don't change that mission permission. It is like a MIB in that way. And so we would come back and say controls, literals, operators, those are things where an agent could say I am conformant or not conformant with this particular ADM. We do not support, or we don't have a requirement to support, because we think it's a bad idea, to have operators somehow define their own command opcodes and their own numeric operators in situ outside of the format of an ADM, because that starts getting us back into that mobile code area. Although I suppose there's nothing keeping someone from generating a scripting ADM that just says, I'll take a blob of data and run it as a script. So that is the concept of the ADM, which gives us the data that we can run on, and it is the moral equivalent of a MIB expanded to capture the things that we need. Next slide. No worries. This will go quickly. I will skip over this example because I think we understand the definition, but there are drafts for a bundle protocol ADM, for a AMP agent ADM. What's nice about the AMP agent ADM is that it will say this is the set of literals and command operations and operators like plus, minus, divide, and those sorts of things, and computed data and atomic data that any agent in the AMP system must be able to identify, and therefore it is open to anyone to use in that system. So when you look at your own ADM, you can presuppose that anyone would have everything already defined in the one, and you only have to capture the deltas in yours. Next slide. And this can be my get off the stage slide. In the AMA document, there are a series of example data flows for how we think this would work from a data fusion perspective, from a performance monitoring perspective, and from a control perspective. And there are 6 or 7 of those in here. So my request is there are already a couple of folks who are looking to start implementing AMP. You may have seen some AMP questions come up on the mailing list. We can create a discussion area around the AMA. But the question back is, do we feel that the work in the AMA adequately captures what we think is a requirement to perform network management in this area? And is it sufficient to say that the AMA captures and is the requirement spec for this, or do we want a separate or a different kind of document? And that's what I have. Oh, and then well, then the last part. This slide. On the ADM side, we have, for example, the ADM agent, ADM. Those are text-based open form, and someone has come back and also made a Yang model for the ADM agent to show that what it would look like if we specified these in Yang.
I think you might have just answered my question, Kevin Paul. So you can use Yang, for example, to implement the model that is described in here, and
that's the goal.
That's
yes.
the goal.
I have not done that because I don't know Yang. But someone who is looking to implement this came back and said, I will create a Yang model and the compilers associated with it, which is, of course, specific to AMP and not the overall AMA.
Mark here. During the charter discussion, one of the comment was from the ISG, I guess I don't remember who, but was to have network management being discussed together with the ops people. And given that you seem to have done, quite a good at work, maybe that's the right time to start that discussion, especially also if you're going to start, writing Yang models, which, these guys are kind of experts. So maybe that's the next step, which is look into getting feedback from the network management people, the ops people.
My belief is that the AMA has, there are no known changes that we want to make to the AMA, so I think it's reasonable to send that out to a larger audience. And then the AMP, as we start getting some adopters, is having questions of, well, why does the type look like this or that? But particularly in the overarching concepts, that would be an easy thing to present, and the AMA document is fairly mature. The AMA document was the first half of the DTNMP document that we've been working on since 2011, so it has some heritage to it. Just let me know how we would go about that. Okay. All right, thank you.
Hi, my name is Ron Infeld. I'm with the Netherlands Organization for Applied Scientific Research, DNO. I want to present on IP neighbor discovery. Next slide, please. A bit of history. This is really the work of some BBN guys and one person from Bit9, which was done in the DTN research group in the IETF, but at some point seemed to be abandoned. The 02 version of this draft expired somewhere in 2012, if I remember correctly. And I just contacted them and got their blessing to revive it. So it's really their work. I only brushed it up a little bit. And just to mention that some versions of this have been implemented in both DTN2, the reference implementation, and in IBR-DTN. Next slide, please. The motivation for having IP, for having neighbor discovery in the first place might be pretty obvious. In use cases where you have opportunistic connectivity, or maybe even predictable connectivity, and you will also want to check if you really have the context that you are expecting to have. You need some form of finding out which nodes are in contact or in reach. Also, neighbor discovery has been identified as one of the work items of this working group, so we should do something about it. Okay, the work presented here does neighbor discovery in a way that is external to the bundle protocol. So we're not going through the bundle protocol to do the neighbor discovery. We do it as something separate and parallel to the operation of the bundle protocol and the bundle protocol agent. And this avoids a chicken and egg problem, because if you were going through the bundle protocol, then you would have to know which convergence layer is supported by the nodes that you're in contact with, just to be able to send your neighbor discovery messages. And that might be a bit awkward. We think that, or I think that the draft that is there was already fairly mature when it was in the DTN research group. And it's in the spirit of the charter of this working group to not start completely from the greenfield, from scratch, but to leverage the work that has already been done. And therefore, I took this document as a starting point. And there is some work still to be done, which will be listed on a later slide. Next slide, please. This is to expand a little bit on the way to do it outside of the bundle protocol. This is actually a picture that we use in the EDA MidNet project that it's a European Defense Agency project that I'm working on. And this is also based on the profit model in RFC 6693, where we even have the routing, DTN routing, going outside the bundle protocol agent. And, here the bundle routing, like for instance the profit routing protocol, talks directly over TCP, and is not going through bundles and through convergence layers. And more to the right, the neighbor discovery is going directly over UDP. Next slide, please. So what would be an alternative approach? And I was kind of expecting Kevin not to be here. Oh, well. so I could say bad things about his expired draft, but go ahead, Rick.
Rick Taylor. Just a quick question. Can we go back to the previous slide?
Yeah.
Just out of interest, why are you avoiding the convergence layer adapters for neighbor discovery and bundle routing agent? Why are you going straight down to the TCP? Is that because in the implementations you've been working on, you only really use TCP, well, IP?
Is this about the routing or about the neighbor discovery?
Well, it's about the neighbor discovery because this is the topic, but I suppose the same question applies to routing. Why not use common convergence layer adapters all the way through?
For the, are you saying that you could? You could.
Sorry, you scared me in the back.
I know the problem.
I know with a lot of the way I try and wrap my head around the DTN work is with a classic layered model where the convergence layer, even though they may be a very conceptual layer, exists. I'm interested in why you have circumvented the convergence layer in that diagram. Is that simply because your implementation just uses TCP IP and therefore you don't need it? Or are you proposing that convergence layer adapters should not be used for neighbor discovery?
I don't want to make assumptions on the availability of a convergence layer adapter of any type before I have have been in contact with my neighbors. So.
Okay. Okay.
So yeah, I could say, well, every node should a datagram-based convergence layer that's capable of sending out the neighbor discovery beacons as multicast, but I don't want to do that. Maybe I only have a TCP convergence layer and not a datagram based one. So
Okay.
I don't want to make any a priori assumptions about the availability of a certain type of
Okay,
convergence layer on the nodes that I might be encountering.
Okay, so yeah, this is me. Your presentation is about neighbor discovery over IP.
Right.
So yeah, I was trying to do Kevin's abstract over abstract convergence layers. Ignore me. Carry on.
Can you go back to the slide?
This relates to that. Oh,
yeah.
Oh, I'd like to hear you.
So during or after the Dallas meeting, IETF 92 last year, Kevin sent out the reference to this expired draft, which was useful, I think, to see a different approach. There we have a protocol that goes through the bundle. Yeah, the EDP protocol is usually a DTN application sitting on top of the bundle protocol and sending to a special multicast, I assume the DTN address, DTN colon EDP v1. And the draft says that this is sent over all available CLAs. It's hidden somewhere in an example, but it says that. And I really couldn't figure out how this would work if all you had was a unicast style of CLA.
So let me, Kevin Fall, this provides a little bit of context for how this happened. So this was a while ago. This thing probably expired in 2009 or something, maybe.
10.
Okay, good guess. What had happened was we had operating implementations, and we wanted all the things you said at the beginning. We wanted neighbor discovery. And people had started to build neighbor discovery on IP-only networks.
Mm-hmm.
So this IPND is one example. We did it over Bonjour in a day. And we did it, I think, later maybe on AllJoin, which is another one of these things that can find your buddy. And we started talking about other service discovery and local discovery options. And we thought, really, there's so many different, kind of related directly to your question, there's so many ways of finding something locally that we should pick one of those underneath a bigger neighbor discovery framework. It could be over multiple protocols. So you maybe you saw the example where it did it over all the CLAs at a time. And the other sort of the things we thought about this was at the bundle layer, you ought to be able to tell somebody else who's your neighbor on this network that I also have all these other endpoints you might be able to reach me on. So that way it's called endpoint discovery protocol. And then also there's a bunch of other stuff I might want to tell you, like what the type of clock sync I have, or my notion of time, or whether I can be a custodian, or whether I can be a thing that implements the security protocol, or whatever the favorite parameters are that you want. And that's because of all those parameters are things you would want to convey. We ought to define the messaging in that layer, at the bundle layer. But what we did not successfully do was demonstrate the entirety of this for a couple networks like TCP/IP and maybe raw Ethernet and maybe some other thing, or what you're bringing up, an endpoint that is sort of you have to contact. And so I can't say this thing's anywhere near being ready to be a standards document, but I also hesitate to go down a road that's IP only. And you said in the last slide you don't want to make an assumption about an available particular layer, but if you look at IPND, for example, it does exactly that, right? It depends on UDP, IP, or IPv4 or v6. So I'm not sure what the best, or I don't know what the group wants to do, but my feeling is that the neighbor discovery problem ought to be its own little architecture of how you sit on top of these different things, UCLAs, and then maybe just go all the way down to one of them and say, well, we're going to use that architecture and we're going to make it work in the IP context for whatever, v4, v6, etc.
I would suggest we.
Okay, yeah, that's so
that.
Yeah, okay.
Because of time constraints,
So yeah, so and there are some other issues with this, and this reliance on this CLA EID, which is some sort of glorified MAC address, if I put correctly, and then there's reliance on the dictionary being in a primary block for all kinds of strings. Next slide, please. So the neighbor discovery that's in the draft that I have picked up is indeed based on UDP and IP, so that's a limitation. I grant you that. At the same time, in my use case, the opportunistic network use case, we have a lot of IP. We can even do IP over Bluetooth or IP over 6LoWPAN if we want to. The protocol advertises a source node or node EID, which is pretty close to the node ID that we now have in the revised bundle protocol spec. In the minimal use, without any options, we just learn the IP address of that node by looking at the packet header. The beacons are either broadcasted or multicasted, or in some cases unicasted. But for unicast, you need to have a priori list of potential contacts, and then you use the protocol just to probe whether they are there or not. Next slide, please. This is what the format looks like. And you see this canonical EID in there. That's a phrase coined by the BBN guys, and even in another expired draft. But it's quite similar, if not the same, as the node ID that we now have in the revised protocol spec. Next slide, please. The optional service block allows you to do a lot of things that you were just hinting at. Namely advertise additional capabilities of your node. A few have been defined already. The support for all types of CLAs on the node over both IPv4 and IPv6. I've made IPv6 mandatory now, and in the previous version it was IPv4. Thought that it would go better with the IETF these days. There's this neighborhood Bloom filter thing that you can use to check for bidirectionality, and it saves you from having to exchange the actual EIDs of all your neighbors that you have. And then there's plenty of space for having your private TLVs. And there's also plenty of space for standardizing some more TLV types. Next slide, please. So what needs to be done if we want to use these neighborhood Bloom filters? Then we actually have to come up with a decent set of hash functions, because that's left open in the draft up till now. And I could really use some help with that, mathematically challenged as I am. We would need perhaps a new TLV type, a new service definition for the bundle protocol representation type that we now have, if we are ever going to have any more than just CBOR, maybe JSON or maybe something else. There are a lot of self-delimiting numerical value thingies in the protocol description, and they seem to have gone out of fashion, so maybe they should be replaced by something else. If this is going for standard tracks, we really need to look at the security considerations section, because that's pretty thin at the moment. And then there are some IANA actions that we need to do. I already put in the request for a port number, but I forgot about the multicast address. That will be in the next revision. And if we have these functions, then we have to have some registry to be able to use some index to point at each hash function. Brian.
Brian Haberman. I'm just going to make the comment that if there are issues related to more to a neighbor discovery architecture, like Rick was talking about earlier, then asking IANA for multicast addresses is probably premature.
Right.
Especially, I'm trying to wrap my head around why those addresses really wouldn't just be link local or something that you could locally allocate rather than globally allocate. Because the IPv6 multicast addresses have all sorts of scopes and all sorts of,
Right.
of twists and turns in them that you can take advantage of without actually going to IANA and asking for one.
Okay.
Good luck.
I happen to have a use case where I need a wider scope than link local, but
Rick Taylor again. Having let you finish rather than interrupting, I now see where you're coming from. Is it really that there's three types of discovery that's going on here? There's Kevin's. I am a DTN forwarding, bundle forwarding agent, and I have all these properties that I wish to exchange with other endpoints that have been discovered by my convergence layers. My convergence layers, each convergence layer, no matter what it is, there is some common behaviors in here. The Bloom filter seems to be applicable across multiple convergence layers, no matter what the actual underlying layer does. And then there's the bottom layer, which is for IP. Yeah, we can use IPv6 link local multicast. Should we get an IANA assigned port number, or should we do it as a priori configuration? And so there's IP, well, let's say there's convergence layer specific neighbor discovery parts. There are generic for convergence layer considerations, requirements, tips and tricks, and then there are endpoint discovery principles. And this is more a question to the chairs. Are we about to try and produce or resurrect and update 2 documents to cover 3 topics and therefore overlap and miss bits? Or should this really try and divide it into 3 pieces of work? And are these charter items? And open question.
Mark here. I think, to me, I guess we need a direction from the working group where we should go in terms of neighbor discovery. And, there are different facets of what we all been discussing.
that's exactly what's on my last slide.
So that's one approach, and we have other approach on the table, but we also need people to work on those, right? And so
yeah,
Kevin, I can propose answers to these questions.
Mhm.
No, yes, no, and no. The reason being that I think there's a bunch of stuff in there that probably is applicable, but it should be done in the context of thinking about the discovery architecture that needs at least a little bit of meat on it in order to be sure that you want to have all that stuff that's down in there. And again, you don't have to do it comprehensively, but it's worth thinking about, well, if I need to do this on 5 different kinds of networks and convey this kind of stuff, and I want it to work on IPv4, v6, multicast, whatever, let's make sure we do a little horizontal and enough vertical to actually get it to work.
Well, Ivancic, I think I might be sort of restating what Kevin just said. I think the one question is what is a neighbor definition in the sense of bundle architecture? Until you answer that question properly, discovering it's difficult.
So this is Ed. I just wanted to agree with Will because when we looked at bundle authentication, for example, just defining what the previous hop was a big definition, and we never quite got to what that definition was, and that seems similar to a hop and a neighbor. So maybe at the beginning of such an architecture, a set of terminology associated with this would be really helpful.
Okay. Well, for me, a neighbor is just another bundle protocol speaker. But,
I guess I'm hearing that we just the fact that identify what we want to
So Kevin again, I guess maybe the concrete recommendation is it seems like we need an architecture document for neighbor discovery. Regrettably, we didn't ever do that in DTNRG, and it's unclear whether a DTNRG will continue to exist here in the immediate future. Although if everybody said, no, it's got to go do that, well, then that might change the conversation, but nonetheless. Yeah, well, okay, I mean, we sort of we want boxes, lines, and some ideas about what they do, and then one version that says, okay, when those boxes say IP on them, and now what's a neighbor? Bundle speakers that can talk to each other in one bundle hop would be my definition, but then there's a notion of immediately findable neighbors, and you gotta say ahead of time kind of neighbors, like across the internet, and that might be interesting to have even that definition, which seems like it would go into an architecture type document.
I would like to make the additional point that the conversions layer adapters that we have at the moment, also being inherited from the DTN research group, are also IP based mainly. I mean, there's Licklider, but it has its special uses. But the other two are the TCP CLA and the datagram CLA, which are using IP. So to complement that, I think it would be fine to have a neighbor discovery protocol based on IP.
I'm agreeing with you, but we did all that in the context of an architecture that would admit other CLAs, right? So I'm arguing we should do the same kind of thing for the neighbor discovery piece.
issue.
Okay. This is Nabil Ben Amar from Morocco. I'm an ISOC fellow here to present the drafts related to static routine for DTN. Next slide, please. So the previous works that have been done in static routine in general, so in non-delay tolerant networks, so we have some draft related to static routine in IPv4 and we were not able to find an RFC related to static routine in IPv6, so that we can base on static routine implementation in DTN. So we have in DTN2 available on source 4 and ION DTN for spacecraft also on source 4. Next slide, please. So one of the simulators that have been extremely used in a research area is one opportunistic network environment. So this is the simulator to use for DTN because it implements all the stuff used for DTN simulations as routing protocols, our scenario, our bundle layer, etc. However, it doesn't take into account node addresses. So we don't have in the setup how to manage the addresses. So nothing is displaced in the environment. So still no clear definition of addressing in DTN context, especially for terrestrial use cases, because this is one of the main objectives of this working group. So suggestions have been done for interplanetary networks, like in this document, DTN naming and addressing, Keith Scott in 2008. But we didn't find any things new to how to make addressing, how is naming and addressing in DTN environment. Next slide, please. So we have some examples. We took, for example, the example of a bus. So how to address a node that has no IP address in DTN context. Use domain name, but what is the domain? So still some definitions to have to agree on, so that we can build on this agreement. Nodes owned by a single organization, or nodes in a common area, or local nodes. Nodes used as mules for distant networks. Domain membership could be static or transitory, which leads to the problem of addressing single and multiple multicast nodes, and then somehow tie a resolved address to an interface. Next slide, please. Some terrestrial use cases. So accessing a particular bus for MGM purposes, accessing a particular bus for driver information, roadworks, congestion, or accident notification. So this is a lot of works have been done into FANET environment using DTN networks. So it leads to what we call VDTN networks. So that vehicular networks implementing DTN paradigm. So it can be really used, but we still need a framework of addressing to build in, so that we can specify and define easily the static routine. So here are some examples of these concepts, and this example of the bus, asking any bus to take custody of some user data to be relayed another specified bus. So many examples that we can find. Next slide, please. So what finally the routing table entry will look like? What should a DTN static routing table entry contain? Address, interface, metric, time, etc. So in a lot of documents, official documents, we can find the definition of endpoint and identifiers, but what does it mean exactly? So we want to define the framework where we will work. So what is exactly the addresses in DTN network or DTN context, so that we can agree on and move forward. Thank you, that's all.
Kevin Fall, I have quite a lot of comments, but I'll contain them. One is, I don't think you need to solve the addressing problem in order to have what goes into a table entry. We have done that extensively with string matching, and we've done it so that you can have variable amounts of identifiers in the matching, such that you don't need to fully interpret the address structure ahead of time. Further, of an evolution in the DTN forwarding agents, I think of importance was splitting across multiple destinations and load balancing, and that I didn't see that in your draft document. I didn't see that presented here. So the idea that you would be able to do that was something used extensively across some of the trials that were done. So, and having a single metric, maybe, but when you have it split across multiple paths, I think you need to think about that a little more. So I have a lot more comments, but that's my initial reaction.
And this is just a comment to consider adding some kind of data rate information to the routing table entries, if that's valuable. The time entry is important, but if this is a kilobit per second link or megabit per second link, that may also be information you want to use in your routing discussion or your routing determinations as to where you go. That's all, just something to consider.
Okay, thank you.
This is Rick Taylor again. This is actually a question for Kevin. I've read through your experimental MRC that you put together with Stephen Farrell and I think Scott as well, about the endpoint identifier URI schema thing. Are we going to be using this? Is that going standard to track, or how are we addressing? And this is the co-author is my colleague, who he unfortunately can't make it, so I'm covering for him. What do we put in these endpoint identifiers? And say I have 100,000 endpoint identifiers in my static routing table. Can can I do some sort of common prefix compression on this? And I'm not talking about the string work. Yeah, we can apply computer science to do work on strings, but how can we subnet these things in some way? How do we get an interoperable network? How do I get my network to know where yours is? And this is I get stuck on this. I think Nabil is stuck on this as well.
Yes.
And this is a question for the group. What are we missing? And why can't we find this document which tells us this? Or does it not exist?
Okay. Kevin, Paul, let me make 2 comments. I think it doesn't exist. But because it doesn't exist does not mean you cannot make progress on static routing entries and how to forward things. And that was the point I was trying to make before, is that I can give you, for example, we have ideas such that in the prefix string, in the whatever it's called, the schema, that you would then admit different types of addressing structures after the scheme name. That's one thing that I think DTN has been doing different than most protocols. But what the structure of those things after the scheme name is whatever you like. We haven't dictated one. We used one in all the experiments because it was handy. But as I said, you can still come up with a mechanism in a forwarding agent that doesn't require you to have done all of those definitions if you admit them as string matching as the algorithm used to select the forwarding.
So this is now a question back to the working group. Should Nabil and John treat the endpoint identifier as an opaque string and work on what goes in the routing table entries, i.e. Some sort of data metrics on the link, or that sort of concentrate on that side of it? Or should they try and capture some of this address stuff in here, because otherwise a static routing table entry is just it's a table with some columns, but who's going to look at endpoint identifiers?
All right, so Mark and I were talking about that. Cut everything off so we can actually get out of here time. But I will point out that at the bottom, the very first one we were talking about the charter, we have a work that address. So we need someone to pick up that work and start making strong proposals so we can start bashing daylight out of it and make it look like what we want to do.
I'll take that back to John.
Thank you.
All right, I want to thank everyone for coming, for both presenters for dealing with with getting their information out. Thank the Echo guys for actually making it work. I know how hard it is for them the first session of the first day, so kudos to them. If anybody has anything else they want to bring up, do it now. Go and play. Oh, too late. Enjoy the rest of your meeting. Thank you.
Most likely going to find the same kind of I would have thought, and I worked with them directly, but I would have thought, oh, sure, but we, really, but we needed something to, someone actually, then the DTN guys are another side of the military coffee on that. So, on paper, enough. I agree. I just give me your notes. Yeah, I think it's probably reasonable. There's locally discoverable neighbors. Yeah. So the more you do, describe what I'm trying to do, then you're fine. You don't describe what you're trying to do, then you get people all confused.
Yeah, what does that mean? Well, no idea.